Today we're going to start our unit on rational functions. Rational functions are functions that are written in the form of a fraction, where both the numerator and the denominator are both polynomial functions. So today we're going to be focusing on finding the vertical asymptotes of rational functions. So let's start off with number 1. Here's my first function, f of x equals 1 over x. So we're going to start off by finding the domain. Our domain is when the denominator cannot equal 0. So we know that x cannot equal 0 because our denominator is just x. Now here we have charts that look at what's happening to your f of x, which is your y, as x gets closer to 0. So as x goes to 0 from the left, so see how our x's are getting closer and closer to 0 on the negative side. So it starts off at -1, then it's going to -0.5, then -0.1, it's getting closer and closer to 0. What's happening to my y's? You can see that your y's are getting bigger and bigger, but they're becoming negative. So it's becoming closer and closer to negative infinity. If we look at as x approaches 0 from the right, on this side, as x gets closer and closer to 0, what's happening to my y's? My y's are getting bigger and bigger positively, so this is now going to positive infinity. So whenever we have your y getting closer to either positive infinity or negative infinity, your x approaches whatever it approaches, so let's just say it's letter A, then that is a vertical asymptote. So whenever your y's are approaching infinity or negative infinity, that means in this case x equals 0 because our x's are approaching 0. That's a vertical asymptote. So let's see what this looks like with some other functions. So let's just take a look at number 2. So for number 2, 3x plus 2 over x minus 3, we're going to start off by finding the domain. So we know the denominator cannot equal 0. So solve for x plus 3 on both sides. We know that x cannot equal positive 3. So let's look at what's happening as x approaches. So let's look on this graph. So we have 2, 2.5, 2.9, 2.99, 2.999. So this is getting closer and closer to 3 from the left. What's happening to our y's? It's becoming more and more negative, so negative infinity. On this side, we have 4, 3.5, 3.1, 3.01, 3.001. Again, it's approaching 3, but this time from the right because it's bigger than 3, so it's from the right side. So like we're really approaching 3 from both the left side and the right side now. And if we look at our y's, this one's getting bigger and bigger positively, so this is positive infinity. So what this tells us is that we have a vertical asymptote, so we're just going to abbreviate VA for vertical asymptote, at x is equal to 3. Great, let's move on to number 3. So here is my function. We're going to start off again by finding the domain. We know the denominator can't be equal to 0. This is a case where we have to first find the factored form of this. This is the difference of squares, so we know x minus 2, x plus 2 cannot equal 0. So if we separate them into two separate ones, x minus 2 can't equal 0 and x plus 2 cannot equal 0. We end up with x does not equal positive 2 and x does not equal negative 2. So our domain is x cannot equal both negative 2 and positive 2. We have two separate restrictions here. So let's look at our charts here. So for this table right here, as x approaches, what is this getting closer and closer to? Negative 2 from the, so in this case, because it's on, if this is negative 2, negative 3 is on this side, right? So it's approaching it from the left. F of x, which is our y, is getting closer and closer to what's happening here, positive infinity. On this side, as x approaches, again it's getting closer and closer to negative 2. But if we're starting at negative 1 over here, this time we're approaching it from the right. F of x is approaching negative infinity. Now let's try the second two sets of tables. So this time as x approaches, what is this getting closer and closer to? Positive 2. So this is positive 2. 1 is on this side, so this is approaching it from the left. F of x is getting closer and closer to, look at your numbers, negative infinity. And as x approaches to from the right, because 3 is obviously on the right of 2, f of x is getting closer and closer to, again, positive infinity. So since they're both getting closer and closer to either negative infinity or positive infinity, we know that there's vertical asymptotes at x is equal to -2 and x is equal to 2. So what we can conclude from these three problems, you might have noticed your vertical asymptotes are exactly where your domain is. Right? So just like with your domain, if you're looking for your vertical asymptote, you have a vertical asymptote at each 0 of q of x, which is your denominator. Right? So every time you have a 0 in your denominator, so when you set it equal to 0, that's going to give you a vertical asymptote. So let's take a look at number 4 now. So now that we know this rule, we can use this to write all of our problems. So let's start off with this first problem. So with our domain, we know the bottom cannot equal 0, so we have x does not equal -4. And with our new rule that we just learned, if this is our domain, then our vertical asymptote is that x is equal to -4. It's just a line exactly at the 0 of your denominator. Okay, let's turn the page. So same idea, but things are going to get a little bit more complicated. So for number 5 here, again, we have our denominator cannot equal 0. But for this one, we're going to have to factor it, right? So we want to turn this into, it's a trinomial. What two numbers multiply to give you, in this case 1 times 2 is 2, add to give you 3. So that's going to give us 1 and 2. And so because your a is equal to 1, we don't need to do the box for this one. So this is just x plus 1, x plus 2 does not equal 0. And if we solve these two separately, it's going to give us x does not equal -1 and x does not equal -2. So our domain is x cannot equal -2 or -1, but our vertical asymptotes, we have two lines at x is equal to -2 and x is equal to -1. Okay, let's do number 6. So for this one, we have x squared plus 1 does not equal 0. Be careful, this is not difference of squares because there's no difference, it's a sum. If we try to solve this one, so let's subtract 1 from both sides. We're looking for x squared equals -1. If we try to take the square root of this, can you take the square root of a negative number? No, you cannot. It's no solution. So therefore our domain is all real numbers, and we have no vertical asymptote. Right, so if there's no solution here, your domain can be any number, and there's no vertical asymptote. Okay, one last trickier one here. 6x squared minus 7x minus 5. So this is another trinomial, so x box. We have 6 times 5 is -30 because it's a -5. 6 times -5, -30 on top, -7 on the bottom. What multiplies to give you -30 adds to give you -7. Let's see, 1 and 30, 2 and 15, 3 and 10. So clearly 3 and 10 are the ones that are going to give you -7. Which one of these do I want to be negative? The 10. And so now because the a is 6, it's not 1, we do have to do the box. So we have 6x squared, a goes in the first box, -5, c goes in this one, and then 3 and -10 go here. So let's look at what's going to give us these numbers. So 6 and 3, this is divisible by 3. So we're going to put the 3x up here. 3x times what gives me 6? This will be a 2x. So 2x times what gives me -10, -5. 3x times what gives me 3x, 1. So this leaves me with 3x minus 5 and 2x plus 1 does not equal 0. So these are my two separate equations that I'm now going to solve to get to my domain. And so I have plus 5, 3x does not equal +5 divided by 3 divided by 3. X doesn't equal 5/3. Same thing on this side. You're just solving for x, and x does not equal -1/2. So my domain is x cannot equal -1/2 and 5/3. And my two vertical asymptotes are x equals -1/2 and x equals 5/3. Excuse me. Okay, so we have one last type of problem we're going to learn how to do today, and this is kind of just a review of what we were learning before. In order for a function to be written in proper rational form, the degree of the numerator has to be less than the degree of the denominator. So we look at number 8. So notice how the degree here is the squared, and this is just to the power of 1. So this is greater than this. So we're going to use long division to rewrite each rational function in proper form. So long division, we have 2x squared, remember our zeros, plus 0x plus 0, divided by x plus 3. So this is the case where now we're going to be having some remainders. So same thing we were doing before, 2x squared divided by x. This leaves me with 2x, so I know 2x goes up here. We're going to multiply 2x times x, 2x squared. 2x times 3 gives me positive 6x. Now we're going to change the sign. So this becomes negative, this becomes negative. These cancel out. 0 plus negative 6 gives me negative 6x. Bring down the 0. Now we're going to do negative 6x divided by x. This gives me negative 6. Minus 6 goes up here. Negative 6 times x gives me negative 6x. Negative 6 times 3 gives me negative 18. Again, change the sign. 0 plus 18 gives me 18. So this is my remainder. Excuse me. And this is what I'm going to be using to rewrite my function. So my f of x equals, I have 2x minus 6, because this is what I got from my function. And I'm going to add my remainder. This is how much I still have left over. That's over the x plus 3. So this is my proper form of this function. So when I divided it out, this is the answer I got, 2x minus 6. And then 18 is what I still have left over in my fraction over x plus 3, because that was what it was originally over. Let's try this with a different function. So we have 3x plus 5, no need for any zeros because it's not missing any terms, over x minus 6. So I have 3x divided by x, which gives me 3. 3 goes up here. 3 times x, 3x. 3 times negative 6, negative 18. Change the signs. These cancel out. 5 plus 18 gives me 23. So this is my remainder. So again, my f of x I rewrite is my answer, which is what I got on top, 3 plus what's left over, 23 divided by your fraction, because that's what's still left in your fraction. Cool. Then, okay, let's go up to our last two examples. So for number 10, so for this problem, if you tried to set this one up, it would not work because this number on top, the degree is already smaller than the degree at the bottom. So if you were to try to take this first one, divide by this one, x to the third divided by x to the fourth, this would give you 1 over x. Right? And we don't want that. We don't want a fraction in our answer. So this is already in proper form. So if it's already in proper form, you don't need to do anything. It's already written in the form that you want, so that's your answer. Excuse me. So notice how for this one, the degree on top is bigger than the degree on bottom, so we are going to need to do this one. So we have x to the fourth. It's missing the x cubed, so we're going to put a 0 there, plus 2x squared. It's missing a 0x plus 1, so don't forget all those placeholder zeros. X squared minus x plus 1. And so when we're solving this, same thing we were doing before, we have x to the fourth divided by x squared. This gives me x squared, so that's what I'm going to write on top. Multiply them, x squared times x to the fourth. X squared times negative x cubed. X squared times 1 plus 1 x squared. Change all the signs, so negative, positive, negative. This cancels out. 0 plus 1 gives me 1x cubed. 2 plus negative 1 gives me 1x squared. Let's bring down the 0x. Same thing we just did. First term divided by first term gives me x. So 1x goes on top. X times x squared, x cubed. X times negative x gives me negative x squared. X times 1 gives me plus 1x. Change the sign again. Negative, positive, negative. These cancel out. 1 plus 1 gives me 2x squared. 0 plus negative 1 is negative 1x. And then we're going to bring down our next term, which is plus 1. Same idea, 2x squared, first term divided by x squared. This leaves me with 2. So I have a plus 2 on top. 2 times x squared gives me 2x squared. 2 times negative 1 is negative 2x. Or 2 times negative x gives me negative 2x. 2 times positive 1 gives me plus 2. Change all the signs, negative, positive, negative. These cancel out. Negative 1 plus 2 gives me 1x. 1 plus negative 2 gives me negative 1. This is my remainder because I have nothing else to bring down. So now I'm just going to rewrite my function. Again, it's my answer, so x squared plus x plus 2. And then I still have what's left over, which is the 1x minus 1. I can just write as x minus 1. It's still in my fraction over my original denominator, so x squared minus x plus 1. And this is my proper rational form.